move on the content. So these all are the contents. We have to learn all those things, then only we implement the project. So first introductions, then embedded system, then block diagrams, then recruitment, then embedded C programming. We have to knowledge about PixSimLab software, then CLCD, then tactile switch, then matrix keypad, ISR, timer, as well as the most important thing is project implementation. So introduction. What is microwave oven? A microwave oven is a relatively small box-like oven that raises the temperature of food by subjecting it to a high-frequency electromagnetic wave. The microwaves are absorbed by water, fat, sugar, and certain other molecules. Vibration produce heat. In simple terms, it is an electric oven that heat and cooks food by exposing of electromagnetic radiation. So next, what is microwave oven used for? The number one use of microwave oven by far is to reheat food. A microwave oven is very efficient and reheating food, retains essential nutrients and doesn't make food soggy. In fact, microwave oven great in reheating just about any kind of food. You can cook a lot of food in your microwave oven. It is multifunctional. So next, there are several methods in which microwave oven operate, but in this project we focus on 4 modes which are mentioned here. So the first method is micro mode, and second one is grill mode, third convection mode, and start mode. So now we are talking about use of modes. So micro mode. In this process, the frequency generator inside of the oven works as well as generate high frequency waves which cook food from inside to out, and it requires a maximum power of 900 watt. You can set time and accordingly the food is ready for you. Grill mode. For grilling purpose we can use it. Same as micro mode, we set the time and accordingly the food is ready. We can grill several items like bread, cookies, this type of things. Next, convection mode. In this mode, we can set the temperature and after it will be preheating for 3 minutes. And then we can set the time and accordingly we cook food whatever we want. And the last is start mode. This is very easy to use. In this mode, we just click the start mode option and the 30-second timer will be started. And you can increase the time whatever you want. So these all are the 4 modes which we discuss. Now we talk about the embedded system. So what is embedded system? An embedded system is a combination of computer hardware as well as software designed for a specific function. Embedded system may also function with a large system. The systems can be programmable or have a fixed functionality. Industrial machines, consumer electronics, agricultural and processing industries, device, automobiles, medical equipment, cameras, digital watch, household appliances, airplanes, vending machines and toys as well as mobile devices are possible location for an embedded system. So these all are the example of embedded system. Embedded system are used in wide range of technologies across the area of industries. Automobiles. Modern cars commonly consist of many computers or embedded systems designed to perform different tasks within the vehicle. Some of these systems perform basic utility functions and others provide entertainment user-facing functions. Some embedded systems in customer vehicles include cars control, backup sensors, suspension control, navigation system, and airbag system. Industrial machines. They can contain embedded systems like sensors and can be embedded systems themselves. Industrial machines often have embedded automation systems that perform specific monitoring and control functions. Medical equipment. These may contain embedded systems like sensors and control mechanism. Medical equipment such as industrial machines also must be user friendly so that human health isn't jeopardized by preventable machines mistake. This means they will often include a more complex OS and GUI design for an appropriate UI. At the end, mobile phone. We know that in mobile phones this consists of many embedded systems including GUI software and hardware operating system, cameras, microphones as well as USB and I/O modules. So these all are the example of embedded system. Now we talk about the block diagram of embedded system, how we can implement a embedded system. In the middle of block diagram we see CPU. It is nothing but central processing unit which can take input and process it and produce output. It can perform multiple operations like arithmetic, logical, fetch, decode and as well as execute also. And we need an power supply because embedded system work at DC power supply. It will require some input device. We have required some input devices. So sensors are the input device. There have some ADC which can convert analog to digital signal and it converted to the controller. And after that there have some memory location where all instructions are stored. And again actuator only understand the analog signal. For that we use another digital to analog converter. To work embedded system properly we need some user interface software. So that's why we use the software MPLab describe. This is the block diagram of embedded system. Then we talk about the block diagram of microwave oven. So here there have power circuits. So there have some IGBT, which is nothing but inserted gate bipolar transistor. Then we have temperature sensor, humidity sensor. In PixSim lab there have two LED panel, but we are using 16:4 matrix LED panel. So there have some key metrics. We will discuss all those things one by one. There have some recommended non-variable memory, serial IO interface, AD, PWM, GPIO. So all are connected in between. So this is the block diagram of microwave oven. So now we will talk about the requirements. So to implement the project, we need MPLAB XIDL software, then XC8 compiler. Inside the MPLAB XIDL software, we can get XC8 compiler, then PIC16F88A microcontroller, which was included in PixSimLab, then 16:4 CLCD screen, which also include in PixSimLab, then MKB timer 2 and as well as tactical switch, all are including in PixSimLab. All are the requirements. Then we'll talk about the embedded C programming. So they have some different part in embedded C programming, and to improve the user readability of the code, we use some header file as well as main file. To mention header file, we using .h, and to mention C file, we using .c. So this is the structure of the code. In this way we implement the actual project. So now we talk about the software. So this is the PixSimLab software where we implement the actual project. So now talk about the CLCD. CLCD, or we can say as character liquid crystal display, can display letter, capital or non-capital, doesn't matter, number and pronouns. You can find any type of display in products such as vending machine, 3D printers, etc. In PixSimLab, there are two types of display. One is 16:2 and 16:4. In our project, we use 16:4 display. Now we talk about the tactile switch. These small size switch are placed on PCBs and are used to close an electrical circuit. When the button is pressed by a person, the switch turn on, and when the button is released, the switch turn off. A tactile switch, in simple term, whenever we click the switch, it turn on, and we release the switch, it turn off. So this is the metal plate, and these two are the terminals. So now we talk about the matrix keypad. So this is the matrix keypad. This matrix keypad and in this PixSimLab matrix keypad are both similar. So what is matrix keypad? It is a keypad in which tactile switches connected in a row and column concept. This is used when more number of user inputs are required and still want to save some another IO lines. These keypad are used mostly in telephones, calculators, etc. So there have some VDD. Suppose whenever we press any switch, the following down to 0 and release the switch, it become 1. So there have some triggering method. One is level and another one is edge triggering. In level triggering, we press the switch and the LED will be toggle, means on. And in edge triggering, when we press the switch, it's become on and as well as LED also on. And whenever we release the switch and whenever we again click the switch, it's become off. So there have some input. These three are input, RA0, 1 and 1, which we mention in column, and as well as these four are the output pin, which we can mention in row form: row 1, row 2, row 3, row 4. Now we talk about the ISR. ISR stand for interrupt service routine, and ISR is a software routine that hardware invokes its response to a interrupt. ISR attends to the request of an interrupt sourcing by clearing the interrupts flag and should have register contents that may be affected by the codes in the ISR. It must be terminated with the interaction IETLE. When the interrupts occur, the MPU completes the instruction begin executed. Then it disables global interrupt, enable and places an address from the program counter on the stack. Next, timer. Timer is an important application in any embedded system. Peripheral, which is the default peripherals which maintains the timing of a operation in sign with a system clock or external clock. It has many applications such as mastering time and generating delays, etc. Timer or counter is a software designed to count the time intervals between the event. Resolution, which is also called register with tie, is referring as a changes from one number to another number. It may be up count or down count. Quantum, which depends on the system clock setting. It is a measure of time which is responsible for the trick. Scaling may be pre-scaling and post-scaler. Now let's go into the project implementation. So I just open MATLAB XITL software to perform the coding part. To operate this PixSimLab software, main.c file. So as you can see, this is the main.c file where I written the code all about this microcontroller. So as you can see, this is my code. So in the init config we are doing all the initialization. As you can see in the main function, what I am doing, as you can see in the main function, I just doing the function call. So after that, as you see, there have some small function like time display screen, then clear screen power time display. As you can see, there have some small function like time display screen. After that, menu display screen, then if we scroll down screen, these all are the small function call. Inside this menu display screen, I just mentioned this 4 topic: micro, grill, convection and start. As you can see, there are very small function like time display screen, then there have clear screen, power on screen, then menu display screen, then set time. These all are very small function. Inside those function there are multiple operation occur, where you can see the header file called as main.h, where I just initialize all those. But for an example, turn up we just use 0. Whenever I write the up, it means that the operation will happen. Then as well as whenever I write the on statement will happen. So this is all about the code. I just showing the code. Then I just click the microwave oven and build. After that, it's showing that build successful. That means our code will work properly. There have no error in our code. So now go to Pixim Lab and go to the file section, then load hex, and then so microwave oven hex file is there. So just click the open, and as I am clicking the open button, it's showing that powering on microwave oven. That means our microwave oven started. I just reload the hex file, and it's showing that powering on microwave oven. That means our LED will turn on. Now there have 4 options, as I mentioned earlier that we are working on 4 options: micro, grill, convection and start. So let's see one by one. For micro, we just click 1. After that, it's showing power 900 watts. Then we just set the time. So let's suppose set 06 second and 02 minute. After that, when we proceed further, we just click hash. So click hash, then the timer will start, as well as the fan also start, and the timer will start as well as the fan also start. Now right now, suppose if I stop the cook here, I just click 5 for pause the cook, and after that whenever we need to resume it, just click 4 to resume the cooking. Whatever time are there, on that time it will be continue. So as you can see, after that there have another option called as stop. So we just click the stop button, and whenever we click the stop button, we can coming to the main menu. This is all about micro. Now we will talk about the grill mode. So just click 2 to activate grill mode. Now the grill mode will be activated as same as micro mode. We just mention the time here. So let's suppose 02 second. To further proceed, I just click the hash button to enter. So let's see. The buzzer, it's showing the time up and the buzzer will be activated. That means our cook is ready. The buzzer will be activated. That's why it's remind me our cooking is ready. So the third option is convection mode. Whenever I click on this button, it's showing the temperature and enter the number. Suppose I set the temperature at 200, and then I just click the enter button, means hash button to enter. Then it's showing that preheating time frame 180 seconds. So after the completing this time, it will showing the display where you set your timing, and then as well as accordingly the food will be cooked. After that, it's showing the timing interface, and you set the timing and accordingly it will perform. So last one is very easy mode called as, so let's go to the last. The last one is start mode. We just click the start and the microwave oven will be started. And as you see that there have one option start and as well as resume. Whenever we click the 4th button, the timing will be increased, as you can see in the display. So in this way, whatever time you want, accordingly you set the time. So it's all about the 4 option in this Pixim Lab. So thank you. So this all about the micro app that we have generated. I would like to thank Emertex Technology.